a look at number 1, knowing what AF is equal to and what FE is equal to and so on and so forth, can someone create an equation using the numbers and the variables? Can someone create an equation using the numbers and the variables?
4 over 6 equals 22 over x.
What do you think? Everybody good there? Okay. So now we can just simply cross multiply and solve. And we should end up with a 4x equal to a, did you say 80?
130.
132. Divide by 4, x is equal to, what I heard, I think I heard 33. Okay? And so that tells us the length of ED. Okay? All right, so here's what I want to do. I want to take this a step further. Okay? And so I want to ask, if I take my expression of the 4 over 6 equal to 22 over x, can someone write another proportion that would be exactly the same? As in, when you go to cross multiply, the 4 would still multiply by the x, the 6 would still multiply by the 22. Laura, ideas?
6 over 4 times 6 over 22 equals 6 over 22.
All right, so are these the same? If you flip the left, you flip the right, the 4 still cross multiplies by the x. Chris, did you have a different one?
No.
There's another possibility that we can come up with. Anybody got an idea?
You flip them diagonal.
So just put the fractions on different sides, you mean, like now do the x over 22 equal the 4, or the 6 over 4, like that?
Yeah.
Okay, we could do that. Anybody else? But let's try, and if we can, let's keep the 4 and the, or at least the 4 or the 6 on one side. Like, for example, can I do 4 over 22 equal to 6 over x? As in, I did 4, I took the two top numbers, made a fraction, took the two bottom numbers, made a fraction. Does the 4 still cross multiply by the x? Yes. Does that make sense? So there's lots of different ways that we can write our proportions. Everybody good with that? Okay, so one of the things that is going to be, asked of you is you have to decide whether or not a new proportion is equivalent to the old proportion. And the big test is, well, does the cross multiplying stay the same? That's how you know. Okay? Now, there is a new one that you have to be aware of. Okay? Let's do this. I am going to put it over here. Okay? So I'm going to say like x over 7 is equal to y over 3. Okay? I want you to come up with, if I were to say x plus 7 over 7 is equal to blank, what would the other side be? Yeah.
Y plus 3 over 3.
Y plus 3 over 3. I could add the denominator to the numerator. Now sometimes it gets a little tricky and you have to kind of piece it apart, okay? So for example, let's say I were to take 2 over 4 equal to x over 3. And if I were to write 6 over 4 equals blank. Well, it's the same thing as the one above. Did I add the denominator to the numerator? Is 2 plus 4 equal to 6?
Yeah.
All right? So then we do the same thing. X plus 3 over 3. The only difference is x plus 3 can't combine together. So there's going to be situations where they're going to give you a proportion and they're going to leave the other side blank, and they want to see if you can come up with the equivalent. And what you're going to do is you're just going to try and see if you can find the pattern. Some of them will be basic. Like if I come back up here, they might do x over y equals blank. What would you write? Go ahead, Angel. 7 over 3. Because he figured out, oh, they took the two top numbers, put them above and below each other, and then the two bottom numbers go above and below each other. Okay? So you're just trying to find the pattern. Does that make sense? So that's part of our concept of writing a proportion. You just got to make sure that you come up with the equivalent one. Okay? All right. So coming down here. A scale drawing is a drawing that is the same shape as the object it represents, but the scale is the ratio that describes the dimensions of the drawing related to the dimensions of the object. So, they always on maps give you a scale factor. On blueprints, they'll give you a scale factor. So, for example, on the one that deals with Atlanta, they're saying on that map, 1 inch on the map represents 250 miles in real life. Okay, 1 centimeter represents 160 kilometers. So you've got your scale factor there. 1 inch equals, 20 miles for the one that's dealing with Decatur, and 1 centimeter represents 13 kilometers. Okay, so that's what we refer to as a scale factor. Everybody good with that? All right, so eventually what's going to happen is I'm going to give you two figures. Okay, so I'll go like this. I'll give you two rectangles. And I'm going to say that this side length is 2 and this side length is 5. I am going to say that these two rectangles are similar. That's important. Important means, we're going to learn about this later, is that in order for them to be similar, the ratio of the sides has to be the same. What's the scale factor between the two rectangles? What's the scale factor from the smaller one to the bigger one? 2 over 5, or we could do 2:5, we could say 2 over 5. Okay? So just another example of how it will relate to the geometry. Just like they said 1 inch represents 250 miles, 2 is to 5. All right, so now if I were to make this into, say, a 4, I'll keep it easy, what would this length be? Why 10? All right, because he figured out that you're multiplying by 2. Okay, as in 2 is to 5, as 4 is to blank. Oh, sorry, I should have put an X there. Cross multiply, 2x equals 20. Okay, divide by 2 and x equals 10. Okay, otherwise he figured out you're just multiplying by 2. Okay, so that's where we're eventually getting to. So you have to understand scale factor. Okay, all right, go to the next page. All right, so we're going to use that idea of the scale factor. So the scale in the drawing below is 1 inch represents, 1 inch on the map represents 2,800 inches in real life. How tall is the Eiffel Tower in inches? Not how tall is the Eiffel Tower on the map. How tall is the Eiffel Tower in actual inches? So first concept, you got to figure out that it is roughly 4.5. Okay, so I saw a couple people do the following. 1 inch represents 2,800 inches. And so remember, this is from map to actual. And then that is equal to 4.5 inches on the map to X number of inches for the actual. If you remember yesterday, I talked about the idea of be consistent. So if you need to, assign words to it. Map over actual height, map over actual height. Okay, and so now you're really just cross-multiplying those two numbers, and you get X is equal to, would you say 12,600 inches? Okay? All right. Example 3. You do a 3D scale model of the Reunion Tower in Dallas, Texas. The actual building is 560 feet tall. Your model is 10 inches tall. The diameter of the dome on your scale model is about 2.1 inches. What is the scale used in the model? So, what she did, okay, is she said, all right, 10 inches, okay, from your model, that's the height of the model, and the actual height of the building is 560 feet, okay, right? And then she converted that. She said 10 inches is the same as how many inches again? 6,720 inches, okay? Which means that you can actually divide by 10, and so now 1 inch in the model represents 672 inches in the actual building. Okay, so now that we have a scale factor that we can use, okay, reminder, yesterday we talked about, number 1, try and get the same units, that's why she converted it to inches, okay, and then number 2, always try and simplify, okay, and that makes the numbers smaller. So now, I need to use that scale factor with the dome. With the dome.
Cross multiply.
All right, but I need a proportion in order to do that. So give us a proportion.
2.1 over, no, 10.
Say that again?
10 over 2.1.
All right, so you're not going to use this over here, or you're changing
I
it?
thought we're cross multiplying.
Okay, we will, but we gotta, basically, remember, if I need a proportion, I need blank over blank equals blank over blank. So, how about we use the 1 over 672 equals what?
Oh, 35.6.
2.1 inches.
2.1 over x. So, we're using our scale factor, okay? This is the model to the actual height of the building, model to x, the actual height of the building. And now we can cross multiply, okay? And now we're just gonna do 2.1 times 672, 1 times x, which is x. And so how many inches tall is, or how many inches is the diameter of the dome?
No, I wanted to.
Go
Oh,
ahead.
no, I was just kidding. You go.
1,000?
I was just kidding. I don't even have it yet. 411.2.
411.2 inches, okay? So, do you understand the idea is, we're trying to come up with the scale factor so that we can use the scale factor to answer another question, okay? And again, always try and, like Chris, you wanted to use the 10 inches, but let's simplify and make it smaller. Now, if, just FYI, okay, if they asked for the diameter in feet, if they do this, then do not do this part, okay? Leave it like this. So sometimes it would help to read your question. Don't convert it. They didn't ask whether they wanted it in feet or not, okay? Then I would just do 10 inches is 560 feet equals 2.1 inches to x feet. And now you have your answer in feet, as opposed to multiplying by 12 and then coming back and dividing by 12, okay? So I don't know if maybe that's what you were going to do, Chris, but yeah. If they ask for it in feet, then, leave it, okay? All right, so the last one here, example 4, the perimeter of a rectangle is 132 inches. The ratio of the width to the length is 5 to 6. Find the length of the rectangle. We did this yesterday in class, and you had one on the homework. You should be able to do this.
Oh, go ahead.
So for those people that are catching up, okay, 6x, 6x, 5x, 5x, 5x plus 5x plus 6x plus 6x equals 132. 22x equals 132, x is equal to 6. Did I answer the question? So here's the debate. Do I do 6 times 6 or do I do 5 times 6? Why the 6?
Because length comes second and 6 comes second.
Very good. So he read width to length, 5 to 6, so therefore the 6 is the length, the 5 is the width. So now we do 6 times 6, and we get 36 inches. Okay, all right? So again, very similar to what we did yesterday. Now you can set this up as a proportion, okay, but like I said, I don't want to go that route. I think it's easier just to use our extended ratio, okay? All right. Example 5 is more the same, okay? I want to focus on this question down here, okay? This will be our last one. This is what I was talking about at the beginning. In terms of, they give us a proportion. If this is your proportion, then what would the new proportion be if they rearranged it? Now, the rearrangement has to stay the same. So when you go to cross multiply, 7 still has to multiply by 10. So what would the other fraction look like? What do you guys think?
I agree.
You agree? All right, so let's check it. 7 multiplies by 10, 5 multiplies by the x plus 6, 5 multiplies by the x plus 6. So that is correct, okay? All right? So that's the idea. You just have to be able to, show that it still works, okay?